Hi y'all, here is another chapter 4 inclined plane problem. Here goes. A girl is sledding down a slope that is inclined 30 degrees with respect to the horizontal. The wind is aiding the motion by providing a steady force of 104 newtons that is parallel to the motion of the sled. The combined mass of the girl and the sled is 65.0 kilograms, and the coefficient of kinetic friction between the snow and the runners is 0.150. How much time is required for the sled to travel down a 175-meter slope starting from rest? Okay, we have an inclined plane. We are going to begin by drawing an inclined plane situation. So here is our girl and sled scenario. It is a 30-degree incline. There is, of course, a force of gravity acting down towards the center of the earth. Normal force perpendicular to the surface. The wind is aiding the motion by providing a steady force parallel to the motion, and it is aiding the motion. So it's sledding, we're going downhill. So we have an additional force of 105 newtons, force applied by the wind of 105 newtons. So there's an extra little oomph this sled is getting. The mass of the situation is 65.0 kilograms. The coefficient of friction is 0.150. And we want to know, long term, we want to know time is required if the displacement is 175 meters. And the original velocity is 0. Well, here's the plan of attack. We're going to have to, first off, use the inclined plane and sum the forces to find acceleration. Once we do that, we can go back and we can use some kinematics equations to find time. So we're going to have to use all of our lovely information about summing forces to find acceleration and then use that to find time. There is a frictional force because we're given a coefficient of friction. There will be a frictional force that is opposing motion. Friction always opposes motion. And we also know that our goal is always to get our forces in an XY sort of pattern. And when you're on an incline, we want these forces perpendicular and parallel to that incline. And the force that is not in that particular direction is gravity. So we're going to break that force into parallel and perpendicular components. So the force that is going to be parallel to the incline is this one, and the force that is perpendicular to the incline is this one. So let's go ahead and find the perpendicular and parallel forces right away. Last problem I didn't do this. I want to just show you a couple different techniques. This is going to be a right triangle. If this is 30 degrees, this is 30 degrees. The force perpendicular, this is the adjacent side. So this is going to be equal to the force of gravity times the adjacent side. So we're going to use the cosine of 30 degrees. Force of gravity is going to be mass. Our mass is 65 kilograms times the acceleration of gravity, 9.8 meters per second squared, times that cosine of 30 degrees. When I go through and do the math, the force perpendicular to the incline, I get a weird answer because I have 6 degrees. Yeah, I did something silly. This is a 30-degree incline. Okay, let's see what I got here. So 30 degrees cosine times 9.8 times 65. I end up with 552 newtons is perpendicular. The force parallel then is going to be equal to the force of gravity, mass 65 kilograms, times acceleration of gravity 9.8 meters per second squared, times the sine of 30 degrees. So force parallel will be sine of 30 times 9.8 times 65, and I'm going to end up with 319 newtons if I round that off to 3 sig figs. I'm going to put bubbles around those because those are not the answer, but they're going to be useful down the road. Okay, next thing I'm going to do is we're going to sum the forces parallel and perpendicular to my inclined plane. So just slide this down a wee bit. I want to still be able to look at my picture. So if I sum the forces horizontal to the incline, parallel to the incline, and I'm going to sum the forces perpendicular to the incline. Now, perpendicular to the incline, that's going to be the up and the down forces. In this plane, those forces are going to be equal to 0. The object is not falling through or being shot above that inclined plane, so those forces are going to be equal to 0. In the parallel direction, is it going to equal 0 or ma? Well, this object is accelerating downward starting with a velocity of 0. So in this direction, that is going to be an acceleration, and that's going to equal ma. I'm going to set this up so everything that's up the incline is going to be a negative, and everything that provides a motion down the incline I'm going to call positive. You are the problem solver. You can do it any way you want. So let's write our equations. Forces parallel to the incline. What have I got? I have got this force added. I've got the force parallel, and then minus the force friction. So force applied of 105 plus the force parallel, plus my force parallel, minus the force of friction is going to make my mass accelerate. That's my parallel equation. My force perpendicular, the up forces are going to equal the down forces. So my normal force, this is going to be my normal force, is going to be equivalent to my force perpendicular. Now let's put some numbers with this if I can. The normal force is going to be equal to the force perpendicular. Well, I found that up above. That's going to be 552 newtons. I already found that. So hallelujah, that is done. Now let's go over to this side. Force applied, we are told that's 105 newtons of extra wind that's applied. Force parallel, I just found that, plus 319 newtons. Minus force of friction. Well, force of friction is equivalent to mu times normal force, and this is going to make my mass accelerate. Let's pull this down one more level. I'm going to add those two together, just trying to simplify my equation a wee bit. 105 plus 319, I get 424 newtons, minus mu, I'm told mu is 0.15. Normal force I got from over here times 552 newtons equals the mass. The combined mass is 65 kilograms. That's my mass times A. And A is what I'm solving for. So let's take it down one more level. 424 newtons minus 0.15 times 552. So 0.15 times 552. I end up with 82.8 newtons minus plus 424. The whole left-hand side of my equation to 3 sig figs, this ends up being 341 newtons equals 65 kilograms times A, or acceleration is 341 newtons divided by 65 kilograms. And I ended up with an acceleration rate of 5.24 or 25, 5.25, I'm tempted to round it off to meters per second squared. That's my rate of acceleration down the inclined plane. Now the question that I was asked up above here is, oh, I went way too far. Let's kind of go back to our problem. The question is, how long, I can do this, I can. How much time is required for the sled to travel down a 175 meter slope starting from rest? So we have this bit of data, 175 meters, original velocity is 0, we're looking for time. So now it turns into a simple kinematics problem. Time is my question mark. Displacement is 175 meters. VO is 0. And we know that acceleration. I am tempted to use x is VOT plus 1/2 AT squared. Original velocity goes to 0, so x is 1/2 AT squared. I'm looking for time, and time then is going to be 2x divided by a, or 2 times 100 and I lost my numbers. I got to pull it up a little bit. There we go. 175 meters divided by 5.25 meters per second squared. Let's grab that in my calculator. 2 times 175 divided by 5. Whoops. I hit the wrong button. Divided by 5.25 square root, and I end up with a time of 8.16 seconds. Alrighty, there we go, and we will see you later. Bye-bye.